Lesson 5, Equivalent Statements. Two compound statements are said to be equivalent if they have the same truth value. Examples, number 22. Use the truth table to show that negation bracket open P or Q bracket close is equal to negation P and negation Q. Solution: you draw the truth table. This table is 2 in 1, showing the results for the two compound statements. You have P, Q, follows by the usual arrangement because of 2 power n, where n is the number of sub statements. They are 2, P and Q. So 2 power 2 is equal to 4. You start with Q. The easiest way is to move from right to left. For Q, you assign T followed by F, another T and F. That is 1 to 1. For P, it becomes 2 to 2. T, T, F, F. In order to get this result, first we need P or Q. Remember, here the outcome is false when both are false. Otherwise, it is true at every other point. If you negate this column, truth becomes false, T becomes F, T becomes F, and F becomes T. You have the same statements. For us to get this compound statement, we need the negation of both statements. Negation P becomes F, F, T, T. Negation Q, F, T, F, T. You combine both using AND. For AND, the outcome is true when both are true. Otherwise, it is false at every other point. So you compare this result with this result, and you see that the outcomes for both are the same. For that reason, you have shown that the two compound statements are equivalent. Example 23. Show that P if and only if Q is equal to if P then Q and if Q then P. Solution: you draw the truth table with the two simple statements P and Q and the usual arrangement. First is to get this side. To get this side, the outcome is true when both are true and when both are false. Otherwise, it is false at every other point. You come here, the same statements P and Q, you get this and this separately before you combine their results using AND. This is if P then Q. The outcome is false when the first statement is true and the second is false. You have it in this form. Now you come here. In this part, you have Q first before P. So Q is the first statement, not P. You must take note of that. The same approach, the outcome is false when the first statement Q is true and the second P is false. You have it in this form. You combine both using and. For this connective, it is true when both are true, when both are true, and false at every other point. You check the columns for the result and they are the same. So you have shown that the compound statements are equivalent. We also have tautology, a compound statement that is always true irrespective of the truth values of the sub-statements is called a tautology. Consider these statements. P. Paul goes to school every week. The negation, Paul does not go to school every week. The truth table for P or negation P is as follows. You have P, just a single statement, one-to-one. You have T, F. The negation becomes F, T. For all, it is only false when both are false. We don't have that here. It means the outcome becomes true. Note, tautology only works with disjunction connective. This is the reason you are able to have true all through the table. We also have contradiction, a compound statement that is always false irrespective of the truth value of the sub-statements is called a contradiction. It only works with conjunction connective. The truth table for P and negation P is as follows. You have P, negation P. If you combine both using and, you have a false compound statement. This is contradiction. End of lesson 5.